Welcome to the part 2 of this C for Absolute Beginners tutorial. It's Bright from Bwave ICT and I'm so excited to have you here. In the first part of this video, we discussed a lot of things that included printing numbers and shape using printf, printing output using puts, comments in C, escape sequence, data types, variables, and size of operator. I also left you with a code challenge and we walked you through how to solve questions of that sort. Today, we would be looking at even more concepts. Let's take a quick delve at what we'll be looking at. Today, we are going to talk about format specifiers in C, arithmetic operators in C, augmented assignment operators in C, math functions in C, constants, changing the value of the variables. We'll be having our second challenge of this tutorial to help you understand all the concepts we'll talk about. So let's get started. The topic we want to consider now is the first, which is a format specifier in C. So we've talked about data types and variables. In our printf statements, we use the format specifiers to tell C kind of data type to print out. We've already discussed about data types, so like string, double, character, floats, those are different data types. And we use our format specifier in C to tell C the kind of data type to print out. This works with variables. So we could come here and say a variable of a character data type, and this variable would be stored as grade, and then we set it equal to A. So work with a format specifier, we could come here and say printf hello, your grade is, now rather than writing A here, we will use a format specifier. So we do that by using a percentage sign here and now write the name of the format specifier, in this case C. We come here, put a comma and write the variable name, so grade. Doing this is the general way to use a format specifier. When we print out this, you can see here it says your grade is %C. Now let's go ahead to print this out and see what would have as our output. So you can see here returns your grade is A. It doesn't return your grade is %C, and this is because the %C here is a format specifier in C. So there are different kinds of format specifiers in C and they have different uses. The syntax to get a format specifier is to use the %sign. So this sign is the general syntax to get a format specifier. Now, after this syntax, you have to tell it what specifier you want. And it's going to allow the program to print out various data types depending on the format specifier we use. So there are some format specifiers that we'll make use of a lot of the times, and one is the %s. Now this is used to get a string. We also have the %f, we use it to get a float. We have %lf, we use it to get a double. We have %d, we use it to get an integer. Now the %n goes ahead and prints nothing. The %% prints this as a character, and these are other ways we could use the format specifiers to add a decimal precision, minimum field widths, and then left or right align our codes. Now let's go ahead to check out how we use the %sign. There's one format specifier that's very popular and we are missing it, and this is the %C, which is used to get a character. Now we've done that example before of the %C, But let's go ahead and do an example for all of these format specifiers in C. So we want to use a variable now, create a variable called character. We create a variable of an integer. We'll create a variable of a character string. We'll go ahead to create a double. We'll create a float, and let's deal with these basic data types first and see how we can use our format specifiers. So let's say our first character should be of name, and we'll use the square brackets in here and write Bwave as our name. Now we'll put the Bwave in between quotes, and that's that. And we come here to grade. Now we'll set this grade to B. We come to our integer value, and we could put something like an age, and our age should be, let's say, 50. We'll come here now to double, and let's say percentage, no, let's just say CGPA in our CGPA, double, and let's say we have 4.9. We use the floats and print out some kind of number which is also a float, so we'll say 5.3. Now let's see how we use our format specifiers for each of these. So for the character name here, if you watch, we have two characters now. Let me briefly explain this. We have two characters here, and one has a square bracket, and one has double quotes, the other has single quotes. So what exactly are all of these? Now, this is a data type of character, but this is a string and not exactly a character data type. So this is a character string. It means a collection of characters. So rather than just having B, we have Bwave, which is a collection of other characters. This is a character string. And so to be able to tell C that I want to print out a character string, we'll go ahead and put a square bracket in here. We'll talk more about character strings when we get user inputs later on. But for now, just know that this is a character string. Now to print this out, we use the %s. So I could come here and say printf, and come inside the double quotes and write hello Bwave. Now, if I write hello Bwave, it's going to print out Bwave. But now let's how to use a format specifier. So I'm going to say hello %s, and come here now, and what is the name of the variable that stores %s? The name of the variable is name. Then now I can easily go ahead and this would print out. So let's check this out now and see what we get. We have hello Bwave. Meanwhile, here we have hello %s. So for us to be able to use our format specifiers, we just have to specify it here and with the format specifier, and go ahead to call the variable name where we have our format specifier. We also have another variable called grade, and this is a character variable. So to print this out now, just copy this now and come here. Now rather than using %s, we'll use %c, and the name of the character variable is grade. So all we have to do once again is call the name of the variable and then the format specifier for it. When we print out this, so let's put a new line here, sorry, and a new line after printing hello b. So in the next line, it goes ahead to print hello b. We could go on and on for the integer, for example, and the format specifier to print out an integer is %d. So we come in here and write the name of the variable which stores the integer. In our case, the name of the variable is age. So we come here and print out hello 50. Now let me also put a new line here. Then when we print this out, it says hello 50. Meanwhile, we are using a format specifier. Could go ahead to print a double now, and to print a double we use the LF, and here we can say CGPA, which is a double. When we print this out, we get hello 4.900. So it gives it a lot more precision in our double. We could go ahead and do the same thing for a float, and to get a float we use the %f, and we come here and write num, which is number. Now if we print this out, we get our number, so we get 5.3000 and all of that. So this is how to work with format specifiers. Basically, they are very useful, and as we go ahead with our tutorials, we'll see how these format specifiers are useful. But now let's talk about something. And if you go ahead now and let's say in a double, we go ahead to print something like an integer. So we use format specifier %d. That is, we use a format specifier which is not originally it. So rather than using %lf, we use %d, and watch what will happen. Code. You can see here we have hello -171798, and basically give us a bunch of random errors that's not supposed to be so. So it doesn't actually print out the expected results because we didn't use the correct format specifier. So you always want to make sure you use the correct format specifier. Now in this character string, imagine we use something like an F here for floats, and we try to print out this. You can see it says hello 0.000 hello B. So it's totally made our program run in an abnormal way. So that's it for format specifiers. You want to make sure you're using the right format specifier for right purpose, or else you run into errors. Now let's look at the format specifier n, because we've said that n here prints nothing. So here now, when you use a wrong format specifier, from what we've just explained, it's going to print out an error for you. So if I'm supposed to use a %s and I go ahead to use a %g or a %d and try to run this, it's going to print out an error. But in our case, let's go ahead and use a %n to see what it's going to print. Now you can already guess what we are going to print, which is %n, which prints out nothing. So first, once I run this now, you see I'm printing out nothing, like precisely nothing. It doesn't give us those weird characters it does in the first place. So I can simply use %s now, print back what I wanted to print, which is hello B in this case. So you can always use the %n to print out nothing. And this way I'm supposed to put my new line character. Now if we run this, it prints out really nothing. Now when we use the %n, it's more helpful if we don't want to print out anything. So for example, if I come here now and I use the %s without specifying what variable, and we run this code, it's going to print out a bunch of random errors for us. If I come here and I use the %d, going to also print out a bunch of random errors for us. It's print out random numbers that in this case we're not looking for. So that's an error. Why did it print this out? Because we did not actually tell it the variable where we are specifying from. So we only printed out a print statement with a format specifier, but it doesn't know the variable where we are getting from. Which data type do you want us to print? You're telling us an integer, but then there's no integer variable. So that's why it's giving us this error. To fix it, we'll put a comma and then the name of the variable. But let's use a %n to see how this %n really works. Now I'm going to print out a hello %n with no variable, and when you run this code, you are going to see that you have no errors whatsoever. That's because of our %n. So this is how the basics of how %n generally works. Just print out hello, but if we come here now and print out d, it's going to print out errors for us, like hello 171 and all of that. Now you know how %n works. Let's talk about the % character and how that works. So using the %% gives print out this sign for us. It just print out this character for us. And what do we mean by that? For example, I want to print out this character, this % character. So I want to say I got 80%. So I got 80%. Now let's try to print this on the screen and see what we'll get. So it says I got 80. You can see my % is missing, and I could go on and on trying to fix this out, and maybe really difficult. But when you put another % sign before it, so it's going to eventually print out this % sign for us. So I got 80%. Now let's see what this would print out. It says I got 80%. So this is how to use the symbol, this % sign, to go ahead to print out our symbols for us. Now let's look at this decimal precision. So you know, like for our other cases, so if we go back a little now, when I wrote some other kind of numerous code, so now you see this this double. Let's try and run this code now. Want to get rid of all the other codes except the floats, so I can remove them. And try to run this now. So seems like okay. So when I run this now, you can see I have 5.3000000. Yes, that's the kind of precision float gives to it, about 6 digits or so. But I don't want those 0000 to appear, all these whole zeros. I want to give it a precision, like print out 2 digits. So how do I do that? I do .2, and I come here, rather I come to, after my % sign, I come and do .2f here. So this is going to print out 2 digits precision. Now when we print this out, you can see I have 5.30. The rest zeros are gone with the dot. So if I want to print out 3 digits precision, I'm just going to say .3 in this case, and run my code, you now see I have 3 digits there. And if I just use the dots, it's going to print out only 5. It's going to turn this floats now. It's going to print out only one value. Now you could ask yourself, doesn't this print out an integer? No, it doesn't. It still counts it as a float, but we are saying we don't want any kind of a other output. So it's going to hide them, or like an integer that throws them away from our. So this is how to use the dot precision. Now let's look at how to use the minimum field width. So let's just use the 1 here, %1, and go ahead to print this out. So get 5.3000. So use the minimum field width format specifier. We just add the minimum field width we want and put a point after that. So what we are saying, let's use an example now. For example, let me put 8 here, points, and just this. The percent is F, so F for floats, and then 8 points to get the minimum field width. Let's go ahead and compile our program to see what this does. So you can see we have hello, all this gap, and then 5. So it's moved 8 spaces in the field and prints out 5. Now this could be useful. Imagine we want to print out a whole lot of floating point numbers now. So we go on and call these. Let's just leave it with their values. Now we go down and okay, we can now use nu here and use n here finally. So let's go ahead, run this and put a new line each of the code to actually see what it does. Now, when I run this program, you can see I have hello and all the 5 are in precision here. They are going to start 8 spaces after. So that's what the minimum field width does. And if I use this other sign now, this minus sign, they are going to go to kind of left align them. So you could call this minimum field width a right alignment. That is, take our output to the right hand side of the screen, or a left align. Now to get the left align, you use the minus sign here. If I go on to run this program now, I'm going to see that all the 5 are left aligned. So that's how to use these 3 format specifiers. This one is to get decimal precision. This one is the minimum field width, or you could call like right align a item, a output, and this one is to left align it. Now you've known how to use the format specifiers. Let's now move over to arithmetic operators in. So what's an arithmetic operator in C? An arithmetic operator are what we use to do the basic math programs: addition, subtraction, multiplication, division. The operators would use to perform those basic maths functions are arithmetic operators. And there are quite a couple of them, and they are pretty much simple and straightforward. So if I come here now and show you, so these are some of the arithmetic operators. We have plus, we have minus, we have the multiplication, the division, and then some other ones. So we have plus here. This is one arithmetic operator. We have minus. We have multiplication, which is a star. We have division here. We also have this as an operator. And lastly, we also have the plus plus and then the minus minus. So let's go ahead and talk about each of them. This one basically it's an operator that will add 2 numbers. This is going to subtract numbers. This will multiply numbers. This will divide numbers. Now this is going to get the remainder of numbers. Remember, we just talked about format specifiers and the percent sign meant something else. But in this case, this is a modulus. In arithmetic operators, in these concepts called arithmetic operators in C, this becomes a modulus and not longer a format specifier. So this works, all these arithmetic operators work on variables, and basically variables in C. So we can perform these mathematical operations, variables that are stored in different data types. So this, in this case, this is no longer a percent sign that we use to get the format specifier of something. This now is a modulo. And what is a modulus in programming or in C? It's used to get the remainder. So instead of call this a modulus, you can call it a remainder. So this is going to get the remainder of any value we print out. What is remaining? So for example, 4 divided by 2, it will print out the. This is going to be an increment operator. So what's the difference between plus, plus, and plus? This is an addition. It adds up two numbers, and this one increments a number by 1. This also decrements a number by 1 and does not perform the subtraction of parts. Now let's go ahead and use examples so that this will be clear to us. Come here now and copy all of this. So I'm going to walk you through all these examples now, and let's see. So first of all, in our first line here, we are going to first initialize different variables. We have variable A, we have variable B, and we have variable C. So we can write a variable like this, or we could come down and write int B, and then come here and write int C. Now, since all of these are of the int type, there's no need for us to do all of that. So we can just say int A, int, we have, so all these other things are of the type integer. That's what it's basically. And here we are going to say variable A has the value of 9, variable B has the value of 4, and variable C is just a variable, but we don't know its value for now, because we want to check out want to use this whole example to test arithmetic operators in. So variable A here has the value of 9 and it's of the type int. Variable B is also of the type int and it has the value of 4. So to check our first arithmetic operator, we can see this statement here, C equal to A plus B. So A plus B, that is A, which is 9, plus B, which is 4. Well, B, whatever the result is, would be the value of C. Now, this is a way for us to test out our arithmetic operator. So I'm going to come here now and comment the other lines of code that is not applicable to us for now. So I can comment them out and leave only this one. So C is going to be A plus B. 9 plus 4 would give us what? Whatever that result is what we'll print on the screen now. So let's go ahead and check that. So it gives us 13, and of a truth, 9 plus 4 is 13. This is the arithmetic operator that performs an addition. So it has added the result of these two variables. Now, this is why we say arithmetic operators work on variables. It adds their results. So in this case, the plus sign here is used to add the result of 9 plus 4. The other arithmetic operators like the minus 1. So this simply means 9 minus 4, which will give us 5. So let's go ahead and check out what we have in our next code. 9 minus 4. And you can see it here, it gives us 5. So that's the arithmetic operator to subtract two numbers or two variables. Now we can also go to the next one, which is multiplication. So to multiply, you use the star once. Now don't do this, which is a star star. If you do this, you'll probably encounter an error. So let's run this now. You can see we have a red line here, and down our error message is saying invalid type. So it doesn't understand the star star here, like double star. If you want to multiply, just use the single star here. And let's run this now. 9 times 4. So what we are simply saying here is A times B. A is 9, B is 4. 9 times 4. Whatever this prints out would come out here as the variable of the value of C. Now, when we do that, we get 36. 9 times 4 of a truth is 36. The next operator we are going to be looking at is the division operator. So 9 divided by 4 should, what would it give us here? So 9 divided by 4, we now run this code, and you can see we have 2. Now if you do this with your calculator, you're going to get a remainder 2 point something. And this is where you have to be careful using arithmetic operators. The reason why you don't have the points display on the screen is actually because we are using an integer here. So this %d is to print out an integer. And when we use %d like this, it's going to turn the floating value to an integer. It's going to throw away the remaining float values. So that's why when we print this out, we just get 2 as opposed to 2 points something. So how can we get the exact precision? We could come here now and change this to a float. And here we use the %f. So the format specifier we're going to use %f. I could pretty much remove these remaining lines of code since they do not concern us. So what would this do now? It's going to divide it and also print out its results. Going to give us a lot of precision now. Now I can run my code, and you can see we have 2.25000. So we have a lot of the precision now. We have the points, we have the floating points number come back to us because we've done 9 divided by 4. We use a float. But if we use a d here, we use and come here to type in an int, then it's going to print exactly 2. So you want to be careful about that as you use this operator called division, using it with an integer. Now there are still other operators, and remember we did talk about the modulus operator, which prints out the remainder when a number is divided by another. So in this case, A would be divided by B, and whatever the remainder is what would go ahead to print out. So let's do exactly that now and see what would have printed out. What would be the remainder if 9 is divided by 4? And we will change the type back to an int. So we can't use a float, so we can't use the type float and then come here and use the format specifier d. It's not going to work. Now let's go ahead and run this. When we run this now, you can see the remainder when divided by b is 1. And why is it 1? So if 9 divided by 4, it would divide just 1 time, and it would divide 2 times, and it's going to have a remainder of 1. So we're going to have 4 divided by 2, that's going to be 8, but it's dividing by 9, so the remainder is going to be 1. So we get exactly the remainder here. The remainder in this case, 1. This is how the modulus operator works here when we use it for variables. But when we use it here, it actually works as a format specifier. So don't get confused about this. This is an arithmetic operator in this case, and here it's a format specifier. Now we have some kind of more things to do, like the minus sign. So this is decrementing by 1. If I go ahead and run this code now, let's see what we have. So we have 9 here, and it's decrementing by 1, but something is happening. Let me go ahead and show you this. So A is originally 9. Now I want to comment out these two lines. A is originally 9 and B is 4. We are not saying the value of C should be A decremented by 1. When we use the minus sign, we're decrementing by 1. So let's go ahead and run this code. And we see C is 9, but A is originally 9. So if I remove this C is now and come here and print out my %D, it's printing out 9, even though we are doing this decrement. So what exactly is happening? Now let me remove that minus sign and print this out. We get 9. So it's as if it's not working, but it is working. It's working. Why do I say that? Now come here to your next line, and after this decrement, try to see the value of A again. See the value of C now, which is A originally. Let's go ahead and check this out. So here C is printing as 9, but here it's decremented to 8. So what exactly happened? When we use the minus operator after our variable here, we are simply telling this command that C is equal to A, and A is originally 9. So it's going to come here and print 9. Then it's going to come back and read this minus sign, and for its next values after this printing, it's going to now decrement it after it's done with printing out this for the first time. So after this block of code, going to go ahead and decrement it by 1 for the, but when we use the minus operator here, something like this, and now let's see what this is going to print out for us. It says 8. So what happened? There's something called a prefix and a postfix operator, or decrement and increment operators. When we use the minus before the variable, C is going to say int A is equal to 9, B is equal to 4, and the value of C is unknown. Now we are saying C is equal to minus A, and it's going to decrement A by 1. This is going to be the value of C. But when we use the operator here, we are saying C is equal to A minus 1. But in this case, we are saying C is equal to minus 1A, and minus 1 out of A would give us 8, because A is 9, then minus 1 is 8. So this is how about the prefix and postfix. So here is prefix, and if we write our A here, if we come here now and write our minus, this would give us this is a postfix decrement operator in C. So to explain it again so that you don't be confused for the last time, we are saying int has the value of 9, int A has the value of 9, and here we want the value of 9 to decrement. That's why we are saying A minus. But if we use A minus, it's going to first print out the value of 9. After printing it out, it's now going to decrement it for our next set of code. That's why here you have 9, but after then you have 8. However, if we use the prefix decrement operator, it's going to decrement it immediately for this same set of code. So when we come here, we have 8 and we have 8. This is how the prefix operator, decrement operator works. It's the same thing for our increment operator. So when we use the plus plus here, and A is originally 9. Now let's go ahead and see this. So A becomes 10 immediately. But what happens if we use the plus plus after the A? A is going to be 9 first, then after that is going to be 10. Following the same explanation I gave about the minus operator, the decrement operator, as it's called, not the minus operator, decrement operator. The increment operator, A plus plus here, is going to increase this by 1. But when we run it in this line of code, we're simply saying, first of all, give us the value of A. Then after giving us the value of A, now in this next line, increments A by 1. That's when we use the increment operator here. But if we go ahead and use the increment operator here, we are simply telling C that increment this thing by 1 and then print out the value of it for this same code. All right, I hope that was clear enough. If it's not clear, or if you understood it clear enough, come down to the comment section and tell me. I'd love to hear from you. Basically, these are the operators we have in C, and we can use them to add, subtract, multiply, divide, and get the modulus of numbers, as well as increment numbers and then decrement numbers. So go ahead, play with these things and make sure you understand them to the fullest. If you have any questions, ask me in the comments section. We move over now to our next topic for today. Now let's talk about augmented assignment operators in C. So augmented assignment operators in C are used to replace a statement where an operator takes a variable as one of its arguments and then assign the results back to the same variable. What does that mean? You remember we've talked about maths operators, mathematical operators, plus, minus, multiplication, division, modulo. Now, the augmented assignment operators are basically shortcuts that you could use to carry out these mathematical operators in some cases. Now, look at the example we are given here. X equal to x plus 1. So this is the normal way, and we could use an augmented assignment operator to make this short. Now, these are the general syntax for augmented operators we have. So going to be the operator followed by an equal to sign. So this is a plus operator, this is a minus operator, this is a multiplication operator, division operator, and modulus operator. It's going to be followed by an equal to sign, and that's how we get the augmented assignment. So how exactly can we use this? We have some examples. Yeah, for example, let's say we have an integer x equal to 20 and want to add 20 plus 2. So want to do this. Want to do this kind of thing for our integer. So how can we do that? Let's go to code blocks and see now and make sense of how the augmented assignment operator. So we have an integer called x, and x is equal to 20. Now, let's say we want to do 20 plus 2 and store the result of this statement inside the same variable x. So we want to increment x by adding another value to x here, that is 20 plus 2. I want to store the result inside this variable called x. How can we do that? Normally we would come here and do x equal to x plus 2. This x is 20, so it will be 20. The value of x will be 20 plus 2, right? But so if we print this out now, let's print it out to see if we are making sense at all. So percent x. So it's returned 22 where we printed it out. That is 20 plus 2x equal to x plus. Now there's a short form. Rather than writing all of these, there's a shorter way we can do that, and that's the augmented assignment operator. So we could come here and say x plus equals 2. So we can remove this now and run this code. Let's see what it prints out. It gives us 22. So we are simply saying x, this is this 20 plus 2, and store the result back in x. That is x plus equal 2. So rather than writing this long format here, which is x equal to x plus, we could use the augmented assignment of. Now there are a couple of them we can do like that. So we could also do the same for minus, division, multiplication. So let's just go ahead and see those briefly. So one is this one here. It says x equal to x minus 2. Remember, we just did the plus. So rather than write all of that, we could use the augmented assignment operator in this case now to pretty much do our thing. So rather than write this, we can write this, and this is an augmented assignment. So if we comment out this now, let's see the results. 18, that is 20 minus 2. Now if we go ahead and comment out this and work with only this second line, let's see the result. So you see, it still gave us 18. So basically, that's how an augmented assignment operator works. We could do plus, division, multiplication. Now you see the multiplication. So, and then the modulus. Any of these can go. So you could decide to test it out. And rather than going through the stress of writing this long line, use your augmented assignment operator as a shortcut. So that's how an augmented assignment operator works. I wanted to add that on before we move over to our next. Over now to mathematical functions in C. So mathematical functions are just a list of math functions that are available to you, predefined already by C, and you can call them by including the math.h header file in your program. So far, we've been working with this header file, stdio.h. And to use our math function, we have to come here now and include our math.h function as the second header file in our program. Now, immediately after calling this math.h function, you can now work with any type of header file you want to work with at all. You'll be able to work with it. And so there are predefined functions that are already available to you. And just as the name implies, they help you to perform mathematical tasks. For example, you want to find the square root of 16. Let's go ahead and do that now using our math function. So you do something like printf, and in here, you're now going to use the percentage f, which stands for a float. And come here and just type square root. Put it in brackets, and in these brackets now put the square root of the number you're looking for. So 16 in our case, and put your semicolon. If you run this code, you will get the square root of 16, which is 4. And so this is how to use the mathematical functions in C. Now, there are some other mathematical functions. For example, let's say to get the ceiling of a number or the floor of a number. So what are we trying to say here? We want to round our number to its lowest integer or round our number up to its highest integer. So how do we do that? We use two functions called a ceil or a floor. So ceiling stands for up, getting a number to its highest integer, and then keeping our number to its lowest integer. Let's go ahead now and use an example to explain that. So in here, we'll come and use the percent f and just write ceil. So we want to make our number come to its lowest integer. Now, let's say we have the number called 6.9. So if you approximate 6.9 now, you would most likely approximate it to 7 because 9 is very close to 7. But using our ceil function, let's go ahead to see what we get here. When you build and run, you can see you have 7.00. We're forgetting a new line character, so let me go ahead and put that here. New line, so you actually see what we are doing quite clearly. So we have the number 6.9, but we want to floor this number now. So, oh, sorry, we used the ceil and wanted to floor our number. So let's go ahead and use floor. We have 6.9. We want to floor our number. We get 6.0. So you can see we have 6 now as our number. We don't have 6.9 again. It's not approximated to 9, but instead we get only the value floor. Now, we also want to get something like a ceiling of a number. That is the highest integer value we can get from that number. So come here and use the ceil function. Ceil as in ceiling. And let's say we have 6.1. Now, what's the highest integer we can get from this number? Let's go ahead and run this, and it gives us 7. So this is how ceil and floor works. Even though normally you would approximate 6.1 to 6 and you approximate 6.9 to 7, using these functions, you get their floor, their lowest value, and then their highest value. Now there are different type of functions you can use. There are a lot of them, to be precise, but let's look at more now, like to get the power of a function. So let's say raised to the power of, that kind of assignment here. We simply come here and call the POW here. So when you use the POW function, it's going to raise the numbers to a power of. So for example, let's say 4 raised to the power of 3, this instance, and try to run this code now, you get 64. So it's actually going to raise to the power of. Now you can see we're not doing much calculation, just call their built-in functions and it will work using our math.h header file. There are a lot of them. We can get the cosine of a number, the tan of a number. We could also get the absolute value of a number. So we could go ahead and print out the absolute value of a number. And to print out the absolute value of a number, we use the ABS. So what do this absolute value actually do? Let's say we have a number called 43 and we have minus 43 here. So what's the absolute value of minus 43? Let's go ahead and check it out now. And oops, I missed this. It's supposed to be a percent %d for an integer here. So what's going to be the absolute value of 43 minus 43? Now we have a minus sign. So let's see what an absolute value does. And you can see it's print out 43, no longer minus 43. So the absolute value is going to give us its absolute value or its positive value, removing the minus sign. So these are some of the basic math functions. You could go ahead to study about a whole lot of them. There are many. We have the sin, tan, cos, sin, tan. Like for example, the tan here. So if we do tan, it gives us the tangent or tangent of an angle using tan. You could go ahead to use sin. You could go ahead to use cos. So depending on what need you have for it, you could go ahead to do a lot of these math functions. See more of them, just go on Google and search for math functions, and you'll get access to how to call the functions here. Let's move over now to our next topic in C, which is constants. So constants in C are values that cannot be changed. Just as the word implies, constants, they remain constant. How? Let's declare a variable of the type int and say 40, like int age, and we call this 40. And here, let's go on to print something now on the screen. So I want to say OB is 40. So this is what I want to print out. Now let me use a format specifier that says OB is %d and oops, OB is %d. Then come here and write age. So let's run this now. Oh, we forgot our semicolon, so you want to be careful about this kind of mistake. And run this, says OB is 40. All right, now we've gotten that. Now let's say we want to change the value of age, or we want to change the value of age, and we come here and say age equal to 41, and then let's write another printf statement that wants to tell us that will be 41. So let's go and see what this will print out for us now. Oops, I forgot my semicolon. Now I always forget about the new line character, and let's run this again. So here says OB is 40, and the next line says OB is 41. That's because we modify the value here. Now, to stop that, we use something called const. Now, let's try to run this now. And come down here, we're getting an error. It says in line 8, we have assignment of read-only variable age. So we are trying to change the value of age, and C does not understand that because we simply use a keyword called constant. Now, one common practice with constants is that we are going to use a capital letter. So, like if you're using constant, use a capital letter. Now, this is not a law, but it's just a general practice that's now common practice, and every other person does that. So why not you? So it's just used to differentiate between variables that can be changed and variables that you can't change. So you use the capital letter for constants and then smaller letters for variables you want to change. So this is how constants work in C. They are variables that you cannot. Now let's talk about how to change variables in C. I did talk about it when we're dealing with the constant variable, how to declare and assign variables or values that would be constant in C. But I'm going to talk about it again and officially this time. And after now, we would have our first challenge for this video and our second challenge for this series. Now, we just said OB is 40. And at some point in our story, we wanted to print out that OB is 41. So how do we do that? I'm going to remove the const first because you can't change the value of a constant variable. And in here, we are now going to say, in this case, our constant variable is 41. So we want to change our value, the value of age from 40 to 41. Instead of assigning a new value, so sorry, I'm supposed to do int age. Now, instead of assigning a new variable and call it int age 2 equal to 41, we don't have to do this. All we just have to do is come here and write age equal to 41. Now, anywhere we call age in our program after initializing it is going to answer us. So when you call age, you can see this suggestion here from code blocks that is telling you, are you trying to refer to this variable age that is of the type age? That's what it's trying to tell you. So when you type age, it's going to automatically suggest this because you called the variable somewhere. You've initialized and set the variable somewhere else. So anywhere in your program, you could call it. And if we want to change the value, come here, we write the variable name, and then equal to what we want to change it to. So we could write 41. We could go ahead and write 67 and put our semicolon. Now, this is all we need to change our variable. Now, if we build and run this, you can see, oh yeah, OB is 40, and here it says OB is 67. So this is how to change the values a variable. Now, this doesn't work only for age, it works for every other data type, like the character data type, the string data type, every other data type. This works for. So next time you want to change the value of a variable, go ahead and change it comfortably. Over now to our first challenge of this video and our second challenge of this series. I want you to print out all of these on the screen. This little story we have about Peter. The tall guy's name is Peter, and if for each of these would be a new line character. So each of these would be a new line character. You could print it out using multiple printf. But I want you to look at this whole story and identify which values need to be stored in a variable and try to change the variables depending on the place you are in the story. So I want you to go ahead, look at this story now. You will not just print it out on the screen using multiple printf. You're going to look at which values need to be stored in a variable and store them in a variable. Now, change the values as you continue to print your story so that we don't have repetition of characters. Go ahead and try that now using what we've just learned so far about changing variables and storing data into variables. If you cannot do this, you can watch the next part of this video for the solution to this challenge. However, I would want you to attempt it and test your brain. Now, this story does not necessarily make sense, but it's just to give you a hang and tell you or teach you why it's important to store things inside a variable and how you can change the values of a variable depending on your circumstances. Now, let's go ahead and first off, fix it or go ahead and solve this challenge. So right now, I'm allowing you to go ahead and solve this challenge. Pause the video, solve it, and come back and see my solution. All right, guys, over now to the solution of our challenge. Now, this is everything we are going to print, and we are asked to use multiple printf. So I could just basically print every sentence in a printf statement. So I could have 1, 2, 3, 4, 5, 6, 7, 8, 9 printf statements here. So print all these sentences. The purpose of this challenge was to make you understand how to use variables and how to change their values and why it's important. So first off, I want to do this the wrong way and then try to use that example to explain to you the importance of variables and changing values. So this is what I would do. Come to my code blocks here, and I'm now just going to put in printf statements, and in each of them I would add a new line and a semicolon. Now, I can come here and copy this to print out our desired results. Come here and okay, before that I could paste a lot of them, about 9 lines of our code. So I'll just paste them first here, and we have 1, 2, 3, 4, 5, 6, 7, 8, and 9 lines of code. Now come here, copy this first line, copy and paste. I'll come to this second line, copy and paste. I'll come to this third line, copy and paste. Come to this fourth line, copy and paste. Come to this fifth line, copy, paste. Sixth line, copy, paste. Seventh line, copy, paste. Line 8, copy, paste. And then my line 9, I'm also going to copy this and paste it. Now let's run this code and see what we have. Now we have our story complete. It says the tall guy's name is Peter. Peter is 20 years of age and he's a student with a CGPA of 3.9. In Peter's second year of studies, his CGPA improved to 4.3. Because of Peter's appearance, his age was mistaken to 30. But Peter always got angry whenever people told him it was like 30. Peter's third year, his CGPA became 4.6. In Peter's final year, CGPA became 0. When Peter graduated, his age was 24. So people thought Peter's age was 20. Now, we've done exactly what we're asked to do here, but what could be the problem with it? Now, imagine that after reading this story, I am the Peter, and I said, oh, sorry, you are not going to use Peter. That was a mistake by me, and I want you to change the anywhere Peter appears. You should replace it with John. So imagine we have to change John for all our 9 lines, and we have to manually come in and type John, 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 and John, like in all the lines. Now imagine this story had about 200 lines and John's name appeared 120 times. We have to type John 120 times manually by coming to our printf here and saying John, John, John. That would be so burdensome. So what can we do? Remember, we've talked a lot about variables. So why not store the name in a variable? That's exactly what we're going to do now. And we can now come here and say character and name. So the name of this person in question is equal to Peter. Now, in here, what are we going to do? Anywhere Peter appears, we are going to use our format specifier to call it. So here now, we could use the %s and put a comma here and write name. So rather than putting Peter, we could just write name. And while I'm storing this variable with name, I could just store it with n and then come here and type n. But if someone else is reading my code, he doesn't understand what n literally means. So I come here and type name And here Peter is 20 years of age. He's a student with a CGPA of 3.9. We see Peter name appear here again. We come here. Now you can see Peter's name appears a lot of times. So we could come here and put in percent S. So come here and as usual, now copy everything. Peter. No, not Peter, would now put name. And the same thing here, since Peter's name appears in all the lines, so we just want to use the variable name in all the lines. So we come here and put name, and here we also put name. Here too, in our next line, we use name. In our next line, we also use name. And we keep on using name variable to call anywhere Peter is. So for all the lines where Peter appears, we'll use our percent %s now. And this is Peter name appearing again. So I could use my percent %s. And here too, I could go on and use my percent %s. And here I could go on, use my percent %s. So whenever we use percent %s, we are calling a format specifier of our character string. And wherever the initial value we give to this variable here will now appear wherever we use percent %s. So let's go ahead and use percent %s for the lines remaining. And the last line. So if you can see, Peter's name appears only once. Now, let's go ahead and run this code. And we have an error on our hands. And let's try to fix that. Says the tall guy's name is, it's expecting some kind of. Let's go ahead and read the error to see what we have on our. Expected a comma or semicolon before the pref. So here's where our problem is coming from this line. Peter, we're supposed to put a semicolon, and now let's run code. So we see the tall guy's name is Peter. Peter is 20 years of age and is a student with C 3.9. You can see now anywhere Peter's name appears, is supposed to appear, it appears. But we called Peter's name only once here. And so this is a better practice. Now, this is what variables can help. You may be wondering in your mind, but I can go ahead and type Peter everywhere rather than put percent %s. But just imagine I come and I say, no, don't change Peter's name to John. Rather than go everywhere and type John, you can now just type John in one place and say John. And when we run our code, see what will happen. So everywhere Peter's name formerly appeared, John's name now appears there. Because we stored it in a variable, and all we have to do is change the value of our variable. Now, what other things can we put? Look at this our story now. What other things can we put in a variable? So let's go to the original story. Now we are talking about age here, and we have 20 in this line. Now we have 30 here, we have 30 here, and we have 24 as his age here, and we have 35 as his age. So now his age appears so many times, so we could store this age in a variable. So this is what we can come and do. We could say our next variable is an integer of age, and this age should originally be assigned to 20 because that's his original name, his original age rather. Now we also see CGPA a lot: 3.9, 4.3, 4.6, and 4.0. So we could come here and say CGPA is now equal to the original CGPA 3.9. So, and the CGPA would be of the type floats. So come here and say floats CGPA 3.9. What other thing can we decide a variable? Let's look at the story once again. So we have his name, we have his age, and we have his CGPA. Now that should be okay for this story, these three variables used to store different things. So we'll do the same thing we did for our name. Anywhere we have his age here, rather than 20, we use our %s. Percent %d for digits for integers. So come here, %d, and here we have his age again. We'll use %d. So let's go ahead and write this percent name, and then come here, we'll put age integer, and over here we're going to, we have his name here again. So come here, put a comma and write age, and here we have his age again, and we're going to do the same thing, %d, now a comma here as always, and write age because that's the variable name. Now where do we have his age again? Here where we have 24, we have his age, and we have %d. So come here and write age, and then we have his age again here, 35. So come here, %d, write age. Okay, so now everywhere his age appears, we have CGPA too. So everywhere his CGPA is, we just go there and change it. So instead of writing 3.9, we write %f for floating point numbers. You remember that, and here we write CGPA, and here we have his CGPA at 4.3. We'll do %f, and we write a CGPA. Here we also have a CGPA 4.6. We use the %f once again and write CGPA. And for this last one, we have 4.0. We would also use a %f and write CGPA. Now, so we've used all our variables in this project. We've used our printf to print out the story, and then we've used our variables. Now let's run this program and see what. All right, so now we have some kind of issues on our hand. The tall guy's name is Peter, exactly the same line with what we have here. Peter is 20 years of age and he's a student with 3.9 GPA. But we have Peter is 20 years of age and he's a student with a GPA of 3.9000000, and that's exactly what we want. So our program could give us errors here, because if the user reads this, it may be like, no, I don't have 3.90000. So we have an issue on our hands. And then here we say Peter's second year of studies, his CGPA improved to 3.9000. And what we have in the initial statement says his CGPA improved to 4.3. So how are we going to fix this now? Let's go ahead and identify all the errors first. Because of Peter's appearance, his age was mistaken to 20. But we are supposed to write his age was mistaken to 30. And then, so the age and the CGPAs will not rhyme any longer. Now, how can we solve all of these issues? Is there anything coming to your mind? Oh well, now let me show you how to solve it. Remember, the essence of this program is just to teach you how to work with variables and modifying the data as a variable. So let's go ahead now and see how we can modify the data in variable to help us print out our program. Remember how I just talked about to change the value of variables? That's what we are going to do now. Change the value of our variables at different times. So for example, the name is fixed, so we are not going to change it, but the age have to change. So we come here now and say the tall guy's name is this okay. His CGPA is originally this. But in his second year, his CGPA improved to, so we are going to come here now and we're going to come here and make sure that we change this variable. So we would come here and now we do CGPA. And when we type CGPA, it says it knows that CGPA now is a variable and it's telling us it's the variable of the type floats. We press enter, equal to, now what is his CGPA at this time? Let's go back to our this thing. It's improved to 4.3. So his CGPA is going to literally improve to 4.3 and we can write it here 4.3. So in this next line now that talks about CGPA, his CGPA is going to improve to 4.3. So let's copy that line. Seems like we deleted it before. Let's copy it and print F and go on with a, now we use the percent F as usual and print out a new line character. And here we'll write name and CGPA. Then we can do something like this. No, yeah. So now what this thing is going to do, so we could change the value now, Peter, to %S. So now we're changing the value from here down. His CGPA is going to go to 4.3. Now, it says because of his appearance, his age was mistaken to, now the age is mistaken to 30, right? So we'd come here and change the value of the variable. So now the value is 30. Originally 20 for this line, 30 for this new line. We're going to come down now, and now the next line says he always got angry when people told him he looked like 30. So because our variable here is 30, we're going to leave all of this and come down to the next line. And so we can pretty much leave this one as this is not our issue for now. Now, the next place where we have CGPA, in his third year, his CGPA became something. So we're also going to change the value of that CGPA for the third year by saying, so what was his CGPA in the third year? The CGPA became 4.6. So we are going to say 4.6. So we've changed the value again for this CGPA. For this line, we change it to 4.3. Now we are updating 4.3 to 4.6 here. And in his final year, his CGPA became something else. So we could do CGPA again and update this value to something else now. So we could update the value to 4.0. And lastly, we could come here. When he graduated, his age was, so we come here now and also update the value of age. And what's this age at this time? 24. So we write 24 here. And although people thought it's age, so we are going to update the value of age again. People thought his age was 35. So we are now going to update it. So for every time we update our value, it's going to affect the from there down until when we update it again. So we'll update the CGPA and the age multiple times in our program to suit our program. Whenever we have to make amendments, now we just use our variables rather than reading the entire state. And then we have another problem on our hand. So when we come back here, instead of us to have 3.9, we're having 3.9000, and we want to end that. We want to give it a precision. So remember how I told you do that. Use the points, and you could say 2 or 1. So you could use the points 1 anywhere you have this state, since we want only one value after the decimal point. So we could use the points 1 for all of them where we have for all our floating points numbers. So we get the precision. All right, let's try to run our code now. So we have, let's put a semicolon here and run this. And it seems everything works well now because I'm coming. Okay, so let's run this now. Great, so everything works well. It says the tall guy's name is Peter. Peter is 20 years of age and is a student with the CPA of 3.9. Now you can see that those 000 has disappeared because of the precision. Remember when I talked about that? And in Peter's second year of studies, the CGPA improved to 4.3. Now you can now see the improvements. As we change our variables, anywhere we call that same variable, it's going to go ahead and also improve the quality of what we call it. So now I'm going to reduce my screen so that you can see clearly for all of them what we've just done. You could study this code again and again if any place doesn't seem clear, and get yourself familiar with it. So I've reduced it. Now you can see everything we've printed out. You could see all the values we've amended and everything so far. Are there better ways of doing this? Yes. But I want to use this method to show you in details what we've learned so far and how you can modify variables and how you can use the points to get precision and how you can use the formatted string to do a lot of things in your program. Using all of this method will help you to succeed in your, will help you to actually understand what we are saying. So go ahead, study this solution again and again to understand. All right, guys, we've talked about quite a lot today. Another 1 hour of explaining the basic concepts in C. Slowly but surely, we'll start moving to difficult things in C. And the next topic we are going to talk about are conditionals in C. From here on, this could get really complex or really easy, depending on how you understand it. And that would be for our next video. So for our next video, we are going to talk about conditionals. We are going to solve even more tasks, and we are going to talk about logical operators and a whole lot of other useful things. With conditions, we could start making really interesting and exciting programs. I can't wait to bring to you the video of conditions and moving forward some other basic and slowly intermediate concepts. But for now, I hope you understand everything we've talked about. If you don't understand, leave a question in the comment section below. If you understand, please tell me using the YouTube comment section. And if this video has taught you anything in any way, please smash the like button and subscribe to this channel so that when I put my next video, you will not miss it. Thank you so much, guys.